the student absent last period. I think she wanted me to record, so. All right, today we're adding, subtracting, multiplying, and dividing fractions and mixed numbers. I do want to add in a little step before step 1, so we'll call it step 0. Do you think my pen's going to work? Let's find out. Step 0 is to change to improper fractions. It's actually working right now, although my board's moving. Swaying. Secure back. All right, once you change any mixed number to an improper fraction, then we're going to find the least common denominator, LCD, which is the least common multiple of the denominators. And you really just need a common denominator. It doesn't have to be the least, but it's just helpful. Then you're going to rewrite each fraction using the LCD so that both fractions have the same denominator. Then we'll add or subtract the numerators. Keep that common denominator the same. And then the last step is always to simplify. So if you get down to 4/8, always make sure you reduce it to 1/2 so that you don't miss a half point for not simplifying. All right, our first one, 4/5 plus 2/3. What would the least common denominator be? 15. So we need to make them both become 15. To do that, we'll multiply this one by 3. Whatever you do in the denominator, you have to do in the numerator also. The other one, we need to multiply by 5. And so we'll get 12/15. Oh, a heart just showed up. How?
You click the text button.
Well, that was actually my fault. But I didn't click it before. I'm so glad this is on a video. I can show this to the tech people.
It's on text.
It's on text again. How?
No, you're on the first one.
Yeah.
All right, real slow. All right, now we add the numerators. We're gonna.
You didn't write something.
Okay. Just make my fingers sore.
You're on text.
It must be right clicking or something to activate
Are
that.
you using a different finger now?
Yeah. Did you notice?
Yeah.
22/15. Leave it as improper. If you really want to change it to mix, you can, but you don't have to. Reduce it if you can, but that one's not reducible. Try the next one on your own, and then we'll change to mixed numbers. We should be getting 9/28. So we should have multiplied this one by 4 and this one by 7. When in doubt, you can always just multiply by the other denominator. That helps, but. And that gets us our 9/28. And then always double check. Factors are only 3, 9, and 1, and so they don't have any foreign factors, so we circle. All right, the last two, I actually added these on this year, are mixed numbers. You can add mixed numbers as long as they have common denominators, but a lot of students will mess it up, especially when they're subtracting. And if the second mixed number is bigger than the first one, you actually have to borrow from the whole. So I suggest, as I said in the directions, to change to improper first. And then you'll just follow the process like we did above. You're less likely to make a mistake. Remember, whenever you change to improper, don't include the negative. So this is 3 times 2, which is 6, 6 plus 1, which is 7. Then you can tack on the negative, which is -7/3. And I always leave a little bit of space because I'm going to multiply that by something. 4 times 3 is 12, plus 1 is 13. So 13/4. Now, find a common denominator. What should that be? 12. So multiply this one by 4 and this one by 3. And so we'll get negative 28 twelfths plus 39 twelfths. And then remember, when you're adding numbers with different signs, you're really subtracting. So 39 minus 28 is 11. And the positive had the bigger number, so it's 11 twelfths. Change this one again to improper. So we'll get 16 thirds. Minus 11 sixths. What's our least common denominator? Kara? 6. You can do 18, but if you do 6, you only have to multiply the first one by something. So it makes it a little bit easier. And we should get 21 sixths. Can we reduce? They're both divisible by 3. I'm running out of space. So we get 7 halves, which is 3 1/2. Just leave it 7 halves if you want. Okay, so those are the harder problems because they have a common denominator. Next up is multiplying and then dividing, which does not require a common denominator. Okay? Rather, you're just going to multiply the numerators together, multiply the denominators together, and simplify. So straight across the top, straight across the bottom, and simplify. Same thing with the mixed numbers. You want to change them to impropers first. But I also want to jot down, you can cross-reduce to make the number smaller if you want to. Now, some of you won't want to, and that's okay. But it can make some of the math mental instead of having to use a calculator for some of the bigger numbers, like example B. And I'll show what I mean by cross-reduce when we get to example B. I'm just going to open up my calculator. So for example 2a, multiply across the top. 4 times 2 is 8. 5 times 3 is 15. Do we have any common factors? Can we reduce it? Nope. Done. Okay, now the next one, what I was saying is, obviously the top 7 times 20 is 140. I don't know what 15 times 21 is, like off the top of my head, without doing some multiplication off to the side or reaching for my calculator. So you can cross-reduce. Cross-reduce means reducing the fraction, but not necessarily right on top of each other. So if you notice, 7 and 21, they have a common factor of 7. So if you divide this by 7, you'll get 1. And if you divide this by 7, you'll get 3. So you can reduce 7 21st to be 1/3. And that's cross-reducing because you're not doing it right above, but actually across. This would not work if this were an equal sign in the middle, a proportion. And then 20 and 15 have a common factor of 5, so divide this by 5, we get 4. Divide 15 by 5, we get 3. And then we multiply to get 4/9. Now just to show you below, in case you didn't do that, you would get 140, 7 times 20, and then in the bottom you would get 315. And then you can use your calculator to reduce that if you don't want to sit there. So 140 divided by 315. And I showed you yesterday how you had to hit enter and then change the fraction. You actually can just do math frac right there, and it'll get you 4/9. So if you're someone who doesn't like this cross-reducing, you're kind of not following my train of thought, then ignore me and follow the directions right here. Okay? Looks like my board might freeze. No. All right, in example C, I would probably just cross off the 8s. 8 divided by 8 is just 1. But if not, you can reduce it at the end. Then we'll get 3/9 here, which is the same thing as 1/3. Now, you cannot just multiply these together. You need to change them to be improper first. So we'll have 2 times 2 is 4, 4 plus 3 is 7, so that's -7 halves. 3 times 3 is 9, plus 1 is 10, so it'll be -10 thirds. And then it's up to you whether you do want to cross-reduce. The 10 and the 2 could reduce to be 5 and 1. Or you can multiply straight across the top and straight across the bottom. Make sure you notice that the 2 negatives get us a positive. And then could we reduce that? They're both even numbers, so you could at least factor out a 2. We'll get 35 thirds. Last operation is division. So division, if you remember, division of a fraction is the same thing as multiplication of its reciprocal. So that's what the steps are going to tell us to do. We are going to flip the second fraction, which means writing the reciprocal of it, and we'll change division to multiplication. And once you've done that, all the problems will look just like the ones we just did. Follow all the rules for multiplication. Go across the top, go across the bottom, and reduce. You can cross-cancel once you've flipped it, if you want to. So we're going to change division to multiplication of the reciprocal. The first fraction stays as is, always, 4/5, but this will become times, flipping our fraction, 3/2. If you'd like to cross-reduce now, you could with the 4 and the 2. Or you can just multiply to get 12/10, and then reduce that to be 6/5. Each of those are divisible by 2. Same thing with our next one. We're going to take the reciprocal of our second fraction. So it'll be times 5/2. And I'm going to, for this one, show cross-reducing, just to kind of mix it up. So if you're a cross-reducer, the 5 and the 15 are both divisible by 5. So that will get me 1 and 3. And the -8 and 2 are both divisible by 2, which will get me -4 and 1. So I'll get -4 thirds. If you don't like that method, multiply across the top to get -40, multiply across the bottom to get 30, and you would still get that same answer. Okay, now this last one, put a couple stars next to this. It's going to take 3 lines of work. Okay, we first need to change to improper, then we need to flip it, then we can multiply. Okay, so 5 times 3 is 15, plus 2 is 17 thirds. Leave this a division symbol for now. Do not try to flip it and change to improper, because a lot of students forget to flip it. Change to improper, we get 5 times 6 is 30, plus 4 is 34 fifths. Now, this problem looks like our last ones. Now we'll change this division to multiplication of the reciprocal. So 17 thirds times, oops, I didn't flip it, 5/34. And again, I would probably cross-reduce because I like to. 17 times 2 is 34. So if we divide 17 by 17, you get 1. Divide 34 by 17 and you get 2. We'll get 5/6. If not, you would get 85 over 102 and then reduce that and get 5/6. All right, now example 4. Some of you will just take and multiply these together and just do what we did in the previous ones. But you'll get really big numbers. Did anyone start it yet? Working ahead? No. In the homework for tomorrow, you'll see some that have even bigger denominators. Like when you multiply all this stuff together, you might get like in the thousands. And then this is in the thousands. And then to find a common denominator between like 2,528 and 3,278, it's really hard unless you multiply them together. So the way I'm going to show it is to leave it in prime factorization. So these are in prime factorization right now. So all we're going to do is we're going to get the denominators to match. So we're just going to compare them. So this one has a 2 squared. This one just has a 2 to the first. So if I want to make this one have a 2 to the second, I need to multiply by 2 again in the top and the bottom. That'll get me 2 squared. Now this one has a 4 squared. This one has no 4, so I need to actually multiply this one by 4 squared also. Okay, now, what's the first one missing? A 3 cubed. Again, whatever you do to the denominator, you have to do to the numerator. Okay? So now, I have double check, 2 squared, 4 squared, 3 cubed. I have 2 squared, because I have 2 of them, 3 cubed, and 4 squared. So this is the same as this. You can now write it as one big fraction over that same denominator. 2 squared, 3 cubed, 4 squared. So this, we have 3 to the first times 3 to the third. That would get me 3 to the fourth. Remember, you add the exponents. You also could just take and multiply them in your calculator. It'll get you 1. But, okay, minus, now 1 times 2 times 4 squared. Maybe we'll just do that. 4 squared is 16. 16 times 2 is 32. And because we have this subtraction, we actually need to use our calculator, perhaps, to finish out the problem. If you don't know that 3 to the fourth is 81, remember on your calculator you do 3 caret 4, which is 81, and then subtract 32 from it. We'll get 49. Now, this denominator, we have 2 squared times 3 squared, no, 3 cubed. So caret 3 times 4 squared. And we get a really big number. Well, I should check and see if I could reduce that. I know that I can't, but only because I did the problem last period. So remember to check in your calculator, type it in, and press your math arrow to fraction button. And if it gives you the same answer back, that means it's in simplest form. All right, last thing are our recipe questions. They give you a recipe for 12 cookies, and it tells you how much of each ingredient you need. It asks us how much of each ingredient is needed for 8 cookies and how much is needed for 16. Every year people look at this and they're like, if I wanted to only needed 8 cookies, I'd make 12 and just have 4 extra. Like, why would I ever want to do this? But I'm still going to show you. Most of you would just be doubling or tripling the recipe. But when you're doing any of these problems and they want you to change the recipe, you always want to do the number that you want in the new outcome or the new recipe over the number of original. That's like in your notes. That's going to get you your scale factor. And then all you have to do is then multiply this by each ingredient. So let's not do both examples. Do you want to do the 8 or the 16? It doesn't matter. The 8, okay. So just scribble out the 16. All right, so the number of cookies that we want is 8. The number of the original recipe was 12. So 8/12 is our scale factor, but personally, I don't like working with big numbers, so I would reduce this. What does it reduce to? 2/3. So now all you have to do is take 2/3 times every ingredient in the list. So let's just make a list of our ingredients. We have butter, flour, eggs, which to cut eggs in half is pretty difficult, but whatever. Sugar, and chocolate chips. So you're literally just going to take 2/3, which is our scale factor, and multiply it. I just listed it up next to every number. Multiply it by each of the ingredients. So the butter was 3/4. The flour was just 1 cup. The eggs were 2. Now for the 2 eggs, I'd probably put 2/1 to force it to be a fraction. The sugar, now the sugar is interesting. It's 1.5, which is 1 1/2. You'll want to change that to improper. So 2 times 1 plus 1 gets me 3/2. And my chocolate chips were 2.5, which is 2 1/2. change that to improper. 2 times 2 plus 1 gets me 5 halves. And then you just multiply. It's like a big long multiple questions in one. So we're going to get, and you could cross reduce this, right? The 3's will cross out to get me 2/4, which is 1/2. So I need 1/2 cup of butter. Flour, I'm going to need 2/3 cup. 2/3 times 1 is just 2/3. For eggs, I'm going to get 4/3, which is 1 1/3 egg. Good luck with that. If it was hard boiled, we could cut it into thirds really. The sugar, actually, these will all cross reduce. What am I left with if they all cross reduce? 1. So I need 1 cup of sugar. And for the chocolate chips, I could reduce the 2's to get 5/3, which would be 1 2/3 cup. You'll notice I'm changing these to mixed numbers, and that's because usually in recipes, they don't tell you that you need 5/3 cups, right? They tell you 1 or whatever. All right, so the homework is every 4 and then 101. And so what I did was I typed out the numbers that you're doing. Like this is the same thing as this. But in case you get confused and just want to jot these down, that way you'll know what problems to complete.